Walk to your air conditioner right now. If it is a central unit, go outside and find the big metal box sitting on a concrete pad next to your house. The one with the fan on top and the metal fins running around the sides. Get close to it. Look at those fins. If there is a layer of dirt, dust, cottonwood, or debris packed into them, even a thin layer that you have to look closely to see, your air conditioner is working significantly harder than it needs to right now, paying significantly more to cool your home than it should, and wearing itself out years faster than the manufacturer designed it to. The frustrating part is that what you are looking at is not damage. It is not a mechanical failure. It is not something that requires a technician or a replacement part. It is dirt, and it is costing you money every single hour your system runs. To understand why this matters so much, you need to understand how your air conditioner actually removes heat from your home. Because most people think of it as a machine that produces cold air. It does not. It moves heat. There is an important difference. Inside your home, there is an evaporator coil. It is usually tucked inside the air handler or furnace unit in a closet or utility room. Warm air from your house gets pulled across this coil by a blower fan. The refrigerant inside the coil absorbs the heat from that air. The air comes out cooler on the other side and gets pushed through your ducts. The refrigerant, now carrying the heat it absorbed from your home, travels through copper lines to the outdoor unit. That is the metal box outside. Inside it, there is a condenser coil wrapped around the inside of the cabinet and a large fan on top. The refrigerant releases the heat it collected from inside your home into the outdoor air. The fan pulls outside air across the condenser coil to carry that heat away. Then the refrigerant goes back inside and does it again, continuously, for as long as the system runs. The efficiency of this entire process depends on one thing above everything else: how effectively the coils can transfer heat. And heat transfer depends entirely on airflow across those coils. The refrigerant inside the coil can only release heat as fast as air moves across the outside of it. Restrict the airflow, and you restrict the heat transfer. The refrigerant cannot dump its heat fast enough. The system has to run longer to move the same amount of heat out of your home. It uses more electricity. The components work harder. They wear faster. The fins you looked at on the outside of your outdoor unit are the surface area of the condenser coil. Those thousands of thin metal fins exist for one reason: to maximize the surface area available for heat transfer between the refrigerant and the outdoor air. When those fins are coated in dirt, dust, grass clippings, cottonwood fluff, or anything else that restricts airflow through them, you are directly reducing the heat transfer capacity of the entire system. A coil that is 30% blocked is a system that is working 30% harder to move the same amount of heat, running longer, consuming more electricity, stressing the compressor more on every cycle. The compressor is the most expensive component in your air conditioning system. Compressor replacements run anywhere from $1,500 to $3,000 on a residential unit. And the number one cause of premature compressor failure is the system running hot because it cannot shed heat efficiently. Dirty coils kill compressors. Not immediately, slowly, over 3 to 5 years of running at elevated temperatures and pressures on every hot day of every summer. Here is why this happens faster than most people expect. The outdoor unit sits outside, all day, every day. The fan pulls air through the coil continuously whenever the system is running. That air carries everything floating in it: grass clippings when you mow, cottonwood in spring, dust constantly, fine soil particles, pollen. The coil fins are designed to maximize surface area, which means they are also very effective at capturing airborne particles. It is the same geometry that makes them good at heat transfer. a lot of surface area, tight spacing between the fins. A light coating of debris starts developing within the first season of operation. By year 2, it is noticeable if you look closely. By year 3, on a system that has never been cleaned, the restriction to airflow is measurable in both electricity consumption and system performance. The indoor evaporator coil has the same problem from the inside. Your return air brings dust and particles from inside your home. The evaporator coil is cold, which means moisture condenses on it whenever the system runs. That moisture is sticky. Dust that passes through the air filter and reaches the coil adheres to the wet surface and builds up over time. A dirty evaporator coil restricts airflow through the indoor side of the system the same way a dirty condenser coil restricts it on the outdoor side. The system has to work harder in both directions simultaneously, and it runs longer to achieve the same result. Your electricity bill goes up. The temperature in your home is slightly harder to maintain on very hot days. You turn the thermostat down slightly to compensate. The system runs even longer. Every dollar of that increase in your electricity bill is the system paying for its own neglect and operating costs. Quick question before I keep going. When was the last time anyone cleaned the coils on your air conditioning system? Not change the filter. Clean the coils themselves. Drop it in the comments. If you have never done it, you are in the majority, and that is exactly why I'm making this video. I want to know how many years people have been running their systems without knowing this needed to happen. Now let me talk about the filter, because there is something about filters that most people do not understand, and it is making the problem worse. Most people know to change their air filter regularly. They do it once or twice a year or when they remember. This is good, but there is a counterintuitive problem with certain types of filters that is worth knowing. The thicker, denser filters marketed as high efficiency, the ones rated MERV 11, 12, 13, and above, are extremely effective at capturing fine particles. They are sold as better for air quality and allergy sufferers. Both of those claims are true. But those same dense filters restrict airflow more than a standard filter. Your air handler blower is designed to move a certain volume of air against a certain resistance. A very restrictive filter increases that resistance. The blower has to work harder to pull air through. In some systems, the airflow drops enough that the evaporator coil gets too cold and starts to ice over. A coil covered in ice cannot absorb heat from your home at all. The system is running but doing nothing useful and potentially damaging itself. A filter that is too restrictive for your specific system is worse than a less efficient filter that allows proper airflow. The right filter for most residential systems is a pleated filter in the MERV 8 range, changed every 1 to 3 months, depending on how dusty your home is. Not the thick MERV 13 you change twice a year. A moderately efficient filter changed frequently keeps more debris from reaching the coil and maintains proper airflow at the same time. More expensive filter changed rarely is worse than cheaper filter changed regularly. The coil does not care about the filter's efficiency rating. It cares about how much dirt reaches it. There is something else happening inside your system that almost nobody talks about, and it compounds everything I have described. Refrigerant charge. Your air conditioning system is designed to operate at a specific refrigerant charge level. The right amount of refrigerant for the specific coil sizes and line lengths in your system. Even a small deviation from that specification, slightly low or slightly high, reduces efficiency and stresses the compressor. Refrigerant does not get consumed like gasoline. A properly installed system with no leaks will hold its charge indefinitely. But systems develop small leaks over time. Connections that were not perfectly sealed during installation. Vibration gradually working on fittings over years of operation. The refrigerant slowly escapes. By the time a system is low enough on refrigerant that it stops cooling well, it has probably been running slightly low for a year or two. The entire time it has been running less efficiently, working harder, and wearing the compressor faster than a properly charged system would. The only way to know the refrigerant charge is to have a technician measure it with gauges. This is not something you can check yourself, but it is something worth asking about when you have a technician out for coil cleaning. A system with clean coils, proper airflow, and correct refrigerant charge running efficiently will outlast a neglected system by years. Okay, what do you actually do? The outdoor coil you can clean yourself, and it is not a difficult job. Turn the power off to the outdoor unit before you do anything. There is a disconnect box mounted on the exterior wall near the unit. Pull it open and remove the disconnect block, or flip the switch inside. Do not skip this step. Use a garden hose with a standard spray nozzle, not a pressure washer. The aluminum fins on the coil are thin and they bend easily. A pressure washer will damage them.